Extension of the approach. The first concept to be considered is the information models. Digital Container Shipping Association information model is intended to be a translator between the information requirements identified by the business processes and the existing standards for describing reference data relevant to the industry. The DCSA information model 3.0 consists of the following artifacts and products: logical data model, standardized list of data, and data standardization rules. The logical data model is defined as a graphical way of representing a data architecture without regard to the physical implementation of the database management system involved in storing the data, providing information about the various entities or the relationships between the entities. The logical data model details the entities and their relationships with one another. An entity is an object that can have information stored about it, for example, shipment, equipment, and transport. A relation describes the industry data-related rules between two entities. As can be seen, there is a clear relationship between the UNECE multimodal reference data model and DCSA information model, and between the DCSA logical model and subsets of the MMT-RDM. At the same time, the information model is extended with additional artifacts, such as DCSA data and interface standards, which detail both the requirements of the subject area and the practice of using the data sets described by the model. And thus, the following pros and cons of information models can be distinguished. Pros, this is the focus on the subject area. High detail of both the model itself and the artifacts associated with it. If resources are available, then it provides flexibility and efficiency. Cons, this is another set of standards implying the need to solve the problem of extra integrations. Next example, this is an electronic FIATA multimodal transport bill of lading. This is negotiable FIATA multimodal document that is trustworthy and reputable. FIATA EFBL project does not only include the release of the EFBL data model as an open source standard, but also add a trust and security layer on top of the digital document. The EFBL solution focuses on the development of the document integrity and traceability. Data model for EFBL is fully based on the UNECE MMT-RDM and also utilizes the UNECE recommended code lists. The key artifacts of the FIATA information model, beside the schema itself and implementation guide, consist of the FIATA managed registry and FIATA digital identity. Both of these tools are used to provide trust for the electronic document regardless of the jurisdiction of the issuer and receiver of this document through the trust of the FIATA. Information model for FIATA EFBL also includes EFBL validator. This is the solution that can help recheck the conformity of the EFBL electronic document to the FIATA requirements. Next example is EU-FTI data model. EU-FTI regulation is aimed to solve the problem of unharmonized electronic information exchange for freight transport information in EU. The scope of the regulation is B2G information flow, but key architectural solution can also be used to harmonize the B2B information flow, at least inside European Union. The UML diagram of the EFTI data model is available by the link. Another one example is EU customs data model. This is the model for trans-European customs systems such as CATS, IAS, and ICS. Also, national customs clearance system in the EU. It's a technical instrument that models the data requirements laid down by EU customs legislation, also presents a single authoritative source of information for national customs authorities wanting to make technical development to their own system. UCDM is defined as fully compatible with the World Customs Organization's data model. The EU customs model is an excellent illustration of the problem of unharmonized top-level standards. These are the UNECE data models such as MMT, BSP, or ISCDM, and the WCO customs data model. UNECE has repeatedly initiated activities to map data models for the international supply chain with the customs data model, the result of which should be the creation of so-called cross-border Some considerations about information models. In addition to the examples above, there are also many other implementations of the information models that are more or less accepted by the industry. It can be stated that the creation of information models in subject areas is an accomplished fact. From the point of view of multimodal transportation and the global supply chain, such models introduce an additional level of complexity to the task of seamless data pipeline. On the other hand, they provide an effective solution to the problem of digitalization of a specific subject area. If we consider such a subject area within the framework of the buy-ship-pay process as a kind of generalized black box, then the presence of information models is more likely to bring good than evil, providing the possibility of integration with one another standard for such black box today, rather than the prospect of harmonizing dozens, if not hundreds or thousands of the implementation for information models of participants in this subject area. Next important topic that should be considered is metadata. We have already looked on metadata earlier, but now it should be focused from the point of view of automation of generating electronic document. The main question about metadata is what needs to be stored in the model for the possibility of its practical application for document processing. About metadata itself, ECON defines metadata as a means of classifying, organizing, and characterizing data or content. In other words, metadata is data about the data. NISO introduced the next types of metadata. This is descriptive metadata, administrative metadata that includes technical, preservation, and rights metadata. Also, this is structural metadata and markup languages. Metadata plays a key role in automating the data processing in general and in application to the process of creating electronic document based on the data model. The MMT stores a large amount of metadata for each information entity. For example, for the information entity issue, you can see aggregated and basic attribute types that all describe it as extra metadata. To automate data processing of data sets, at least the following metadata must be present for each information entity or attribute. This is attribute types such as basic types, numbers, strings, dates, business information entity or aggregated business information entity. Also, this is dimensions. This is information about mandatory or optional kind of this attribute. Relationship between attributes for aggregated business information entities. Also links to the data sources with which this attribute should be associated. And also it's good to store links to the visualization. This information may be stored in various forms, depending on the processing method that is intended to be used. This can be tables and database description in the form of markup languages like XML or JSON and other approaches. Tools for working with models and metadata. Previously, in the example of creating electronic document, we used the Microsoft Visual Studio Code tool. It's one of the widespread and free text editors popular among developers. At the same time, not all data operations were conveniently performed using this tool. For example, generating an XML document form from an XD schema. There are more functional specialized software tools for working with data, for example, GFX or AutoXML Spy. You can get more information about each of them by the links provided. Next important topic is the concept of data processing. Data processing is an execution of a certain set of operations on such data during the main business process. The main business process should be understood as a sequence of actions for the movement of the goods and vehicles in the supply chain, accompanied by certain documents and/or data in the information flow. The relationship of such flow is shown on the figure. Thus, the information flow accompanies the material, goods, people, and vehicles, and financial flows, and together they form the execution of the supply chain. The data in the information flow is generated based on and as a result of the states in which the other two flows are located and operations with them, leading to changes in such states, transitions to the new states. In turn, the data leads or initiates such state changes. This can be shown as a linked graph in which nodes represent states and arcs represents operations. In the context of the information flow, the states of material and financial flows can be described as a set of attributes, data, and operations as the functions on this data set. The result of which will be the appearance of a new data set in a new state. So this can be described as a function f on the set 1, that result of which is a set 2. Thus, data processing is a set of functions that performs the transformation of a set of data from state 1 to state n, which will be the final state for the considered business process. Considering the fact that even for simplest process, the number of such functions can be large and grow exponentially with an increase in the number of states and connection between them, it's advisable to consider the possibility of enlarging the entire possible set of functions to a limited number. An example of such aggregation would be the CRUD model that is derived from the relational database management systems, that is C is creation of a new set of data, R is read or receiving the set of data, U for update or change the data in data set, D for delete the data or delete the set of data. The complexity and diversity of the original set of data transformation functions can be hidden inside such 4 beta functions as the operation of executing a function on a function. You can see the formula, where f is a generalized function from the CRUD set of functions for processing data, and fa, this is for function that performs transformation initial state to the final state. The advantage of this approach is the ability to create a standardized application programming interface or API with a clearly defined set of commands that can provide functionally complete coverage of all required data operations to solve the problem of data processing in an automated form. Next concept is the data pipelines concept. We have already talked a little bit about data pipelines early, but this is a key concept for interoperability. This concept was proposed by UNECE and provides data directly at its source and only once, and reuse it through the supply chain regardless of the mode of transport, party, or regulator that needs access to the data. The key principles of the data pipelines concept are the following. Capture data from the right person at the right place at the time. Capture once and use many times in the supply chain. Data is passed to the pipelines and its point of origin. And data can be retrieved from the pipeline either on demand or pull the data, or by sending it to a recipient, push the data. The main purpose of data pipelines is to improve the quality of the data, ensure a smooth transfer within the information flow of the supply chain, in particular by shifting the paradigm from the concept of document to the concept of data set. The key difference between these two concepts is that the document model is based on a rigid or paper structure of the document, even in electronic form, while the data set model involves the presentation of information in the form of flexible structures, data sets. And this could be for business information entity and aggregated business information entities, which can be formed from reference data model on the fly at the request of the recipient of information and in the form that meets the requirements of a particular business process. The transformation concept. As mentioned above, each subject area to one degree or another tends to create its own information model. Such models are created at the level of regional associations, organizations, by means of transport, states, specific enterprises, and sometimes even within one enterprise. For example, financial, accounting, and operating models. Ideally, these models should be harmonized with the corresponding reference data model, and the mapping is kept up to date. More often, the reference data model is used as a starting point, after which the derived model continues to live its own life, or the model is created from the scratch without regard to the standards. Therefore, in order to transfer information, document, or dataset from one participant or step of business process to another, provided that they use their own information models, such data must be transformed from one model to another. At the same time, the transformation does not imply any functional data processing. That is, data content should not be changed as a result of such transformation. Such transformation can be described as a function T on the set of data that provides equivalent set of data to. One can think of transformation as a translation of text from one language into another, in which the content of the text remains unnamed. Transformation can be considered as a special case of data processing and described as a subfunction of the update function, data modification. However, it's proposed to separate it into an individual concept and a dedicated implementation due to the key features. Transformation doesn't and mustn't change the contents of the data and their meaning, semantic. The transformation doesn't and must not change the author of the data or the person responsible for the completeness, correctness, legal significance, etc. Transformation can be performed in a separate from the main data processing flow. That is, it can be performed in parallel or at a different time, as well as in other technological way as processing. Jurisdictions in this case should be considered not only as legal jurisdictions, states or legal associations, but any entities with their own set of requirements that affects the data sets processed as part of the information flow of the main business process flow. Therefore, transformation can be depicted as a function over a set of data sets of requirements. So we can describe it on the second formula as a T on set of data, set of requirements from jurisdiction 1 and set of requirements from jurisdictions 2 that produce the new version of initial data set 1. Next topic is generating the documents from a model. When generating documents from a model, we can talk about creating one or more representations of corresponding document or data set. This is document schema as a separate document, its definition or description of the document, document form or blank document, document structure without data, populating a document with data or linking document form to data sources, see our topic for metadata, and also visual representation of the document in form of XSLT transformation, PDF, or in any other form. Each of these views has been discussed in detail earlier. The key point in this stage is the ability to generate this view in automated mode from the tool we have chosen or from their own information system. For example, in GFX software, we can use it for generating XSD schema of the document and XML document form. Transition from documents to API. The automation of the document processing based on the data model allows us to operate the data sets, but not the documents. This in turn lets us to create dedicated API for each data set from the original document. Thanks to such interface architecture, any data set can be accessed in a standardized but fine-tuned way. As a next step to expanding the API and moving to the data pipelines, could be the implementation of automated negotiation of such document requirements using the mechanism of the XML transformation or XSLT. Such a transformation can be implemented as a schematron by the sending side, which is requested in the same way as any document via CRUD API and executed on the receiving side. Generation API from a data model. UNECE initiated two API-related projects. It's RDM2 API, a methodology to deliver API specification and JSON LD dictionaries with existing UNECE reference data models at the starting point, and API Town Plan. It's an architectural framework and governance model for the delivery of APIs and JSON LD dictionaries by subject matter experts and business domain. Information about both of these projects are available by the link provided. The focus of these two projects is to bring standardization and UNECE methodology to the world of web APIs. The present situation with API development is very similar to the one as it was with earlier attempts of digitalization of paper documents. There are hundreds and thousands of implementations, and they all are different. The advantage of the approach advocated by UNECE is the association of the API with the data model. This provides the ability to reflect the standards implemented in the data model directly in the API. In addition, due to the fact that API itself can be described as a set of structured data, it becomes possible to generate such a description from the data model. Of course, such an API still needs to be associated with the data access functionality in the target information system. However, firstly, this process must be performed in any case, and secondly, it can be implemented much easier due to the presence of a description generated from the data model. Another approach that echoes the UNECE initiatives is the concept of distributed conversion. If in the case of the RDM2 API project, it's supposed to create a centralized repository of requirements and descriptions of relationship between the data model and the API, or subject areas created and maintained by UNECE experts, then in the case of distributed conversion, a bottom-up approach is proposed. Thus, the implementation of the logic of linking the specific subject area implementation with the data model is directly handled by the owner of the subject area. In this case, the domain may not be the entire industry, but one information system of a particular participant. The prerequisite for the creation of such an approach was the situation of the presence of many information systems of different owners and conditions of general destruct of each other, a conflict of interest and competition for customers with the impossibility of independently covering the entire market. As a result, the need for a universal language of communication, which can be MMT or DM, and the creation of custom translators, converters for a specific subject application. This approach makes it possible to implement solutions that can comply with UNECE data modeling requirements without waiting for the full implementation of the standard description for the API by UNECE itself. In addition, it solves the problem of trust to purity of a conversion, since each converter has an explicitly defined owner. At the same time, the described approaches do not contradict each other, but can complement each other, filling the descriptions of the requirements for the API as a project API town plan, for example, from the subject areas expert, while simultaneously fulfilling the proof of concept of such descriptions through the practical application. changing the application point of the API when applying this distributed conversion approach. Another advantage of the proposed approach can be a change in the point of application of the API from the client or front-end model, that is the API for document or dataset, can be moved to the server or backend model, the API for transforming the subject area into a data model. Also, distributed conversion can be used as a tool for converting information models among themselves if there is a common vocabulary which can be as in fact a core component library. The approach described above, which involves the use of information models and specialized tools to integrate such models into core business process, has both advantages and disadvantages. Advantages are connectivity of the entire set of data and metadata within the information model, providing the ability to effectively manage changes and reduce the impact of errors provoked by the human factor. The possibility of full-fledged processing of electronic documents, including transformation when changing modes of transport and jurisdictions. The possibility of implementing highly loaded electronic document management systems. Disadvantages are the high cost of tools used, both purchased and homemade IT solutions, high requirements for the expertise of specialists operating the information models as a core of the information system. It can be concluded that the described approach has significant potential, but is available only in large projects in which the advantages provided by this approach outweigh the disadvantages caused by its high cost. I want to thank you for your attention and remind you to look for the full text of this guidance on the untitled.org site. Thank you and bye.